Hello, crowd. Hello, internet. We are Brickland. I run Brickland. It's a small studio in Gothenburg. If I can get some images. Just a moment. Here. Fantastic. We're a small studio from Gothenburg, Sweden, which I run with Ragnar. We are 8-ish people strong, mixed background, 3D generalists, designers, animators. Our customers are agencies, production companies, film producers and directors. Automotive industry is big in Gothenburg, so about half of what we do is aimed towards Volvo, Lincoln Company, Polestar, and Geely. This presentation will have two parts. I will do the first part, and it's about how I animated a car using MoGraph and keyframes. And the second part is VR design process and workflows. So we did a film commissioned by MFX in Gothenburg. It's for Lincoln Company. It was for a Chinese car convention at the beginning of this year. And they wanted to show all of their platforms that the car consists of. And this is what we came up with. So yeah, thank you. This was all produced in about 4 weeks and rendered in Octane in Compt in After Effects. I will more discuss the animation and prepping on this talk. So the first topic that I would like to speak about is splitting geometry. When we see the car, they had some parts were very big, like the hood, for example, and other parts were very small, like screws and different engine parts. So we had to have a system where we could split geometry efficiently. And I'm an old 3D Studio Max guy, so I always bring in my teapot. It's actually a plugin in Cinema 4D, and it's very handy. And then I bring in Voronoi fracturing objects, and there you have the classic Voronoi fracturing look, which isn't very suitable when you're dealing with cars. However, in the source of the Voronoi fracture, you can feed almost anything. So after testing some stuff, I found out that you can put in a spline in the source object, and then the object is divided according to the spline. which is extremely flexible if you want to cut up geometry. You have different settings for counts or steps, and you can even have vertices. So where you have a vertice, and you add a vertice, you add a cut there. So this way you have precise control over how you cut your mesh, which is, I'm not sure it was intended to work this way, but it's very robust and very nice. And since it's a spline, you can adjust the normal angle of the spline if you want to have some angles on your cuts, which is very handy. I didn't use this, but it gives a lot of creative possibilities when you do your cuts. Another way of doing cuts on a mesh is with the matrix object. So you can add a matrix object and use that instead of a spline, which is also very handy. So now I've added a matrix object, and I put that into the source object, and now the matrix object is controlling where I want my cuts to be. And I'm not restricted to just a line of rows, but like volume cutting in this way. If I want the slice look, I'll just have one row and increase the numbers in Y. And I have a live cutter this way. And the fracturing object accepts effectors, so you don't have to divide your mesh into a fracture object. You can just add effectors like regular MoGraph effectors inside of the Voronoi fracturing object, like so. So here I have a couple of effectors, just planar effectors that are offsetted in space. I have scale, rotation. Yeah, I think it's just scale and rotation. But adding them into the Voronoi fracturing object, you can do some funky animation pretty easy. And everything here is live, so the only thing that is keyframed is one planar effector that goes. So it's two keyframes, and it's all parametric and fast. So this was the way I used to cut up the object using this is a gearbox, I think. Cool. So the other method that is important when dealing with animation is the ability to control the center of the pivot. Where is the animation coming from? So here I have a plane. I'm just gonna disconnect the faces, so I have lots of objects. So disconnect options and make sure that the preserve group is off. And then I can do polygon groups to object, and I have a row of faces I can animate. So if I want to have the pivot on the center of each face, I just bring up my axis tool and align the pivots to each face. If I feed these objects into a fracture object, I expose the objects to the power of MoGraph, and I can transform them. So feeding them into a fracture object, adding a planar effector, having a rotation of 90 degrees, I can run it through the objects and they will rotate, like so. But they're rotating from the center of each face. I'd like them to rotate from the base of each face. The way the fracture object works is that it takes object and it doesn't care where the pivot is situated. The first step, however, in solving this issue is changing the pivot point. So I have the pivot point at the base of each object. what I like to do here is have it so it's more like a cards falling. But bringing on the fracture again, you can see that it's still rotating from the center of the object, even though I have changed the pivot point. So I need to solve this in some way. And the way to solve this is that I need to group every object under a null. You have the Alt-G command in Cinema. The problem is that you only group one object. So you need a script for that groups every object under a script. I use HB modeling tool pack, which comes in handy, and that has a script called HB group. So now every object is inside of a pivot point, and the rotation is driven from the null object instead of the polygon plane, and then you have that type of falling look. So the way to offset pivot points is by adding your objects into nulls. And then you can add some different planar effectors or other effectors that perform different tasks, rotation, scale. And you can layer your animation and build interesting results. So this is a mechanical type falling look. And once you try it out on simple geometry, you can bring it into more heavy geometry later on. These are some of the script that does that. The HB modeling bundle, group each by breadth base. Basically, it's just take your objects and place them under nulls, which is very handy when dealing with animation. Yeah. The next topic I like to talk about is mixing keyframe animation with MoGraph animation. Here I have an art object. This was exported into Unity for some sort of exhibition. They wanted this art object that was standing in the museum transformed in a cube. Don't ask me why. But either way, I animated each piece with regular keyframes, and then I put them into a fracture object to add additional rotation. So this is the animation without the fracture objects and the effectors run through. And putting on the fracture with the effectors, you have additional animation going on. One key feature workflow here is to add stuff inside layers, because layers are very powerful in Cinema 4D. Not just because you can unhide and hide stuff, but you can also turn off different properties on each layer. So you can turn off MoGraph, you can turn off animation, you can choose what you want to turn off. So here I've chosen to turn off animation and just showing what happens with the fracture object and the MoGraph animation. So this is what happens. Now I've turned off animation, and now I turn off MoGraph, and this is the keyframe. So I can switch between them. This is good if you want to filter out what you're working with. And you do this so because you want to layer animation on top of each other to make interesting results. I use this workflow a lot on the car itself, because some part needed special treatment when it came to animation, and big chunks of data I could just flush through with, like regular planar effectors and stuff. Adding thousands of objects like this into a fracturing object, it can be quite heavy on the machine. So here I'm down to 5 frames per second, which is basically, when you're animating, you need stuff to be real time. Otherwise, you can't see what you're doing. That's just how I like it anyway. But if I've added stuff into my layer, I can filter out just showing the keyframe animation this time. Likewise, turning off the animation and just showing the MoGraph animation. Just running them one-on-one makes it so it's very fast feedback in the viewport. So layers make it so that you can work very, very smart inside of Cinema. I have, let's see, the rims here. The rims here was animated only with MoGraph and some random effectors. So no keyframes here. The last topic I like to show is custom fall-offing. In doing this type of animation, how an object enters and exits its animation life is crucial. The way that you do this is with custom fall-offs. Then the fall-offs are controlled inside the fall-off tab of the effector. I'm just going to copy it out to a new scene so you can see more clearly what I'm talking about. So this is controlled by about 4 or 5 effectors. You have a rotation effector, scale effector, all controlled by the plane effector. And every effector has different fall-offs, as you can see in the fall-off tab. And those curves determine how the animation starts and ends. The thing about that UI is that it's very small and cramped, but you can tear it off, make it bigger, and then you have your curve showing how the animation enters and how it exits. On the left, it enters, and on the right, it exits. So with this type of big curve, you have a lot of control on determining how the fall-off works. Gonna scrub through a bit here. So, and the thing is with these curves is that you can save them. You have a save preset button. So if you constantly save your curves that you're happy with, you can have your library of own curves. That is very handy and speed up your workflow. And you have this nice icon so you can easily visualize how your curves are looking. So having your own library of animation curves speed up your workflow quite a lot. And I use this on every scene in this animation to have a smooth flow of the animation. So this is a small animation montage. It's just hardware renders with some of the animation that was done on this project. I just want to say thank you. That was not what I was going to say. I'm going to say that that Cinema handle, this is an enormous amount of data, and Cinema handle it better than anyone expected. And we're happy, very happy that it doesn't kill our pipeline with a car like that. Over to Mr. Ragnar. Right.
So, hello everyone. My name is Ragnar, and I'm also representing Brickland. And I'm going to show you two VR projects that we created. The first one I will go in depth, and the second one will just be a couple of quick tips. So, the first project is the 360C, which is a concept car by Volvo. And they are exploring the future of autonomous drive and what you can do with a car when you don't have to drive yourself anymore. So they created a series of interesting interiors where you could work or have a living room or even sleep in the car and wake up the next day in a different city. So our task was to create a safety animation to show the car's communication with other cars and pedestrians and bicyclists. And just a big thank you to all of these who were involved in making this project. And quite early in the project they decided that they also wanted a VR experience, and which was very interesting because we could share the visual style. So I put together this video where I switch between the VR experience and the regular animation. Thank you. Thank you. Okay, so when designing for VR, there are a number of things to consider that are not present when you're doing a regular animation. And the first and the most important thing is to minimize nausea, because you're at this press show where you invite people, and they have to sit through a 3-minute VR presentation. And the last thing you want is for them to feel nauseous afterwards, because they won't have a pleasant show. The second one is to have a presence in the scene. They want to have a nice world to sit in and experience, and also gaze direction. Where the viewer looks is also important with this freedom of 360. So you have to have some way to direct where they're supposed to look. We also wanted visual clarity because of the still limited resolution in this kind of headsets. So we wanted a really clean look with not too much texture or model detail. So to minimize nausea, the first thing we did was to decide on a seated experience, because in these headsets they don't track your movement, only the rotation. So if you stand up and take a few steps, you tend to feel nauseous right away because it doesn't follow you. And you also don't want any large moving objects too close to the viewer. We also wanted this solid point where you would stay throughout the experience and not throw you into different kinds of scenes too much. And our solution to this was these benches. And this is a photo from the actual show. So we would sit up to 8 people on these benches. And this bench is represented in the VR world. And it's throughout the whole experience. And presence is basically about adding some nice subtle animations, this grounded point of view again, and also the sound design is, of course, very important to immerse the viewer. So, like I said, 360 degrees can be too much freedom, and we restricted the viewer to 180 degrees just by making them sit down, because you're not very likely to turn around too much when you're sitting down. So this is a video from the show, and this is what most people looked like when they viewed it. And it might look a little bit boring, but it's actually a good thing, because it means they are following the story. I watched around 200 people go through this, and most of them look like this. You also want to keep the action in the main content zone, meaning if this is you, you want the content in front of you, not too close, because it will feel uncomfortable, and not too far away, because you want to see the detail. And this curiosity zone, you can make it look nice, but don't put too much content in there. You can also use stereo or ambisonic sound cues if you want to make people look. There you can just add a sound there, and they will hopefully turn their eyes towards that. And last but not least, you have to give the viewer some extra time to take in the environment. You can't work with fast cuts or anything. Just keep it slow and nice and respectful to the viewer. The visual clarity, we decided to use a very limited palette, not too much model detail, and practically no textures. So with all these principles in place, we went on to the look development. And our main inspirations were architecture photography, this minimalistic style, and also the really great and fun autonom animation by Foam Studio. And we really liked how they used these color blocks in the city. So this is the first style frame that Daniel made. And the client were positive. They felt it kind of represented the mood that they were after. And then we sketched out the main focus area in the city, where we would spend most of the time. So I sat with Kajsa at Volvo Design and sketched this, which turned into this. And at this point, Volvo and we felt that we were onto something good. A few weeks later, the final look is this. So you have, let me see, the bench and the tree, who they actually created based on our 3D models, which was a very nice mix between the virtual and the real world. We also created some characters using Mixamo and Fuse to populate the city. And now I'm going to take you through the experience. Unfortunately on a flat screen, but anyway. So first we have the bench and the tree, and we give quite some time for the people to physically put on the headset. It can take from 5 to 20 seconds. So that's why it's a very slow start on this. Then you enter the city, and we use this car and this lady, and the way her eyes is, we are very likely to look that direction also. We have this woman stepping out in the road, and there's the car doing the light and the sound signals. And we even used slow motion here to really emphasize the action. So I'm gonna scrub along a bit. Here's the woman ordering the car, and Daniel made some nice motion graphics which were split in depth, which made a really nice effect in VR. Moving on to the next scene. And this, oh sorry, I'm gonna jump back here. Like that. This scene was quite a challenge because we're supposed to follow this car on a road, but remember we can't move you or you will be nauseous. So we decided to basically make a very minimalistic scene, and the only things that are moving are these small trees in the background. And turned out it works well, pretty well, at least from a nausea point of view. And finally the last scene, which was quite easy and fun to make. It's just this calm environment where you can relax and the car drives away to pick up another passenger. You have the falling leaves, some water animation, and just a very relaxing and calm atmosphere. And in the end we give some extra, we put in 10 seconds of black space so the viewer knows that they're supposed to take off the headset. So the workflow was basically just using our previous experience and add this new VR trial and error basically. And the tools we used were Cinema 4D, we rendered in Octane Render, After Effects for the post, Mixamo and Fuse to create the characters, and the Drive plugin for the car simulation, Forester for all the trees and the nature elements, and finally Neat Video to denoise the renders. So a little bit about takes, which is one of my favorite tools in cinema. It's basically an override system which you can get very creative with. You can change the lighting or whatever property in the whole scene. And this gives me a lot of creative possibilities because of how easy and fast it is to use. It also makes our rendering very structured together with the render tokens. And overall it's a huge time saver. So this is one example of how I used takes in the regular animation. So I have all these cameras, and I want to tweak the lighting for every camera. So I have the take system allowed me to use 16 different lighting setups just for this scene. So very handy. And this is the render token, which uses the name from the take, and it means I can set this path and then just leave it for the rest of the project. And also putting the same output path in the render passes. And then I create a different kind of render settings, but the only thing I change here is the frame range. And I also like to use takes to do small position changes to enhance the composition, like this tree here, for example. I raised it up only for this camera. So to render for VR is very easy, actually. You just put this camera tag into panoramic mode, and then under stereo, over under, and that's it. And we rendered in 4x4, 4,000 by 4,000 square. And I wanted to keep the post-production very light because of the high resolution. So I only used the object layer color and the Z-depth. And the render settings were quite low because I rendered, I think, over 4,000 frames in a high resolution. But the neat video also took care of it. So post-production is quite simple. Just some curves, depth adjustments, temperature, and you can do local adjustments, but if you do use masks, you just have to remember to copy them to the other image, or it will look very weird. And finally, some text, which we also rendered from Cinema to put them in the right spot. I'm going to skip through that and just talk very briefly about an interior VR experience, which was for Eaton Systems. And the VR agency out here, Sultan and Sultan, and Kaliber, who made the sound design. So this is a logistics system where they can transport cloth parts in a shirt factory in the ceiling instead of having to push around the trolleys. And interior rendering means huge render times. I mean, yeah, it's crazy. So the solution to this was to use render layers. So one frame like this would take about 5 hours, which makes it very hard to animate. So I made an HDR of the room and hid away all the parts I didn't need, and just kept the occluding parts and the animated parts, and put them in a render layer like this, and an object tag with the same number. So I could go from 5 hours to 1 minute 36 seconds per frame. And my colleague gave me a tip to use this adaptive sampling with a really low setting, because there's so much alpha, then the render can skip through these parts really quickly. And I went down to 23 seconds, which, yeah, saved a lot of headache in this project. So finally, just a screen capture from a small part of this project.
Do you notice that there's no sound of trolleys being pushed around or messy handling of bundles? With Eaton, the system will distribute the material evenly. Every operator can concentrate on the task of sewing, gaining momentum, increasing needle time, and boosting productivity. Not to mention the greatly improved ergonomics of the workstation. The Eaton system closely monitors the production process, instantly reporting what's going on along the production line. You'll be able to see.
So with that, I say thank you, and yeah, enjoy the rest of the day.